back to our session again. We are still looking at some few introduction to our topic of light. We had looked at the types of the sources, luminous and unluminous, and then we have also looked at the different materials that is enveloped, and that is opaque, transparent, and translucent, with all this, some of the few simple examples. And then now, let's look at another new thing that will also guide us so much in light. That is what we call rays and beams. What is a ray? If I ask a question, what is a ray? What is a ray of light? If I can add that to be more specific. What is a ray of light? So imagine someone poses a question to you and say, what is a ray of light? How do you answer that? If someone asks you what is a ray of light, you can define it as a ray of light is a path taken by light. Is that okay? That any direction that light takes is what we are calling it a ray. Is that okay? I've said a ray is a path taken by light. Is that okay? That is the definition of a ray of light. And if we are to use a diagram, a ray is represented using what we are calling a straight line. Sorry, it may not look straight, but imagine that is a straight line. A ray is represented by a straight line with an arrow on it to represent the direction of travel. Is that okay? Should you draw any line and then you don't put the arrow, that one does not qualify to be a ray. Is that okay? Are we together? Good. So we have said ray is the direction or path taken by light. And if we are to represent it using a drawing, we draw a straight line and then put an arrow like I've done. This is showing that the light was moving in the other direction. Failure to put this arrow, that one is no longer a ray of light. Is that okay? Good. That is an array. And then supposing someone talks about beams. The what? Beams of light. What are beams of light? If someone tells you to define beams of light, what can you talk about? If they ask you such a question, beams of light is a collection of rays of light. That if I get a ray plus another ray plus another ray, and then I draw them moving in a specific direction, the collection of those rays is what we are calling beams of light. And we can as well also represent it, as I've said, I can draw like this, draw like this, draw like this. A number of them, because we say it is a collection. But don't forget, we should be having a specific direction of travel. Because without the direction of travel, in other words, without these arrows you see, that one is no longer a beam of light, because it will not be having a direction. And you know very well that light will be traveling from somewhere to somewhere. Is that okay? So it is that arrow that will tell us that this light is traveling from here up to the other side. So the collection of all these one, that is what we are calling beams of light. Is that it? But the single one is called the array. Is that okay? Good. Let me hope we are together. We can now distinguish between what is a ray and what are beams. And if we are to represent it diagrammatically, we can also represent it. We say the ray is the path taken by light, and a single arrow represents a ray. While a beam is the collection of the rays. It can be drawn in that format. Is that okay? Good. And then next, after looking at what a beam of light is, and we have now defined it, Let's look at what we are calling types of beams. Types of what? Types of beams. Types of beams of light. I can't stop there. Types of beams of light. That the collection of light. How many types are we having as far as light is concerned? One is what we are calling it parallel. Parallel beam of what? A parallel beam of light. From the name parallel, that means that it's a group of rays that will move and they will never meet. They move close to each other but they will never meet. That is what we are calling it parallel beam of light. Is that okay? They are parallel to each other. And how do we represent that? Exactly, we can represent parallel beam of light is like that. An example are the rays that are coming from distant object. They come as a parallel. We shall also look at the detail of that when we are looking at the ray diagram. So this is how we present parallel beam of light. This one is parallel to this, parallel to the other, parallel to the other one, and they will never meet. Is that okay? So these are called the parallel beams of light. That is one. And then two, we can call it the diverging beams. What are diverging beams of light? Diverging beams of light are the light which moves from a common point spreading it outward. Is that okay? They originate from a single source, but all of them move in different directions. How do we represent that? That if I have a source here, this ray will move out in that direction, the other one, and this. All these are, this is the source, and now these are the beams. The beams of light. They are all beginning from this point but spreading what? In different directions. They are not parallel. Is that okay? So these are what we are calling diverging beams. They diverge from a common point. Is that okay? That one is called a diverging or a divergent. Isn't it? If you can't call it diverging, you can even call it divergent. Is that okay? Divergent beam of light or diverging beams of, they move away from a common point. Is that okay? E.g. light maybe from a torch, from the bulb, it also moves out spreading. Is that okay? That one is what we are also calling it divergent beams of light. And then lastly, we can look at what we are calling convergent or converging. In bracket, you can call it convergent. Convergent beams. Is that okay? Convergent beams. What are convergent beams of light? Convergent beams of light are the ones that come to a what? They come to a common point. Is that okay? They are the sources of light that move from somewhere and then they all meet at a common point. Is that okay? An example, we can illustrate it like this. That I can have this and then I have light coming from here to that point. I have another one coming here to that point. I have another one coming from here to that point. And then I have another one coming here to that point. This representation is for convergent beams of light. Convergent. From the word convergent, that we meet at a point. Let's converge. Is that okay? We are saying that we meet at a point. Therefore, even that light comes from different sources, but meet at that common point. Is that okay? Is that okay? Good. So an example would be the one forms in a convex mirror. And we shall also look at detail of that as well. Is that okay? So, as we have said, there are three types of beams. We have parallel, the one which do not meet, represented by that. And then we have the diverging, or what we call the divergent beams that move from a common source. Is that okay? And then we finally have convergent, which converge at a common point. So all those are our types of beams. Is that okay? All those are types of beams. So after looking at all this introduction of our light, let's look at something very simple under light. Let's look at something called the propagation of light, or what you can call linear propagation of light. Propagation of light. How do light travels? How do light propagate from one point to another? That's what we're looking at, propagation of light. That can be analyzed under what we call rectilinear propagation of light. Rectilinear, it is this, rectilinear propagation of light. Propagation, rectilinear propagation. What does that word rectilinear propagation of light mean? It is the property that tells us that light travels in a straight line. Is that okay? It is the property of light which states that light travels in a straight line. Is that in straight what? Line. Is that okay? It is the property of light which states that light travels in a straight line. Is that okay? It's a property of light which states that light travels in what? In a straight line. Is that okay? So, it is a study that reveals that when light is moving, it moves in a straight line. Is that okay? That's what we call rectilinear propagation of light. That light travels always in a straight line, isn't it? So the propagation of light is that light travels in a straight line. It will not make a curve, change direction. If it takes this direction, it will move in a straight line. Is that okay? Is that okay? Good. So that is what is under propagation of light. That the fact that light travels in a straight line. How can we prove that? That is it really very true that light travels in a straight line? Is it true? Are we having a proof for that? That light travels in a straight line? Or it is just our thinking that light must be traveling in a straight line? Or there is a proof for it? Let's see. Experiment to verify the rectilinear propagation of light. Experiment to show that light travels in a straight line. Experiment, I can abbreviate, to show that light travels in a what? In a straight line. Is that okay? Or you can say experiment to prove the rectilinear propagation of. You can just say like that. Experiment to what? To prove the rectilinear propagation of light, or experiment to show that light travels in a straight line. So what do we need if we are to prove that light travels in a straight line? We can have a number of the apparatus that we need. We can need at least a minimum of 3 cardboard. Let me hope we know a cardboard. We can get any sheet of strong paper or a box in some good size, and then you drill hole through it. It can be rectangular in this size, and then you drill a small hole. 3 of them, there is a hole through that cardboard. And then you can also need maybe a candle or a source of light. It can be a torch or anything that can produce for you light. It could be a torch. It can be a candle. Any of the two can also work for us. And then we can also need the torch will be acting as our source of light, or the candle. And then we can also need a string. The purpose of the string is for lining them that are in the same line. Is that okay? That is the purpose of the string. And then yourself, you need to be there. What we're calling the observer. Yourself, you are going to act as an observer to see what is happening. This is the apparatus. And then how is the drawing looking like? This drawing. Is that okay? You can set your drawing like this. Will it be visible there? Let me draw it here. Let's have the drawing here. I can have it like this. This is the first one. And then this is the second one. And then maybe the third one, I can arrange like that. And then using a string, you ensure that all these holes, they are at the same level, no hole is above. And then I can now bring, if it is a candle, I can bring it here to produce source of light. Is that okay? And then yourself, you come and observe from here. Is that okay? So you arrange 3 boards. You put one board here, another board here standing, isn't it? Okay? It could be something, maybe if I can use this, it could be like this. Yeah? A very hard one, you drill a hole in the middle. Is that okay? 3 of them, and then you put them in line so that they are the same height. Is that okay? And then the arrangements should look like that. Using a string, you will align them such that the whole are at the same height. So if you put your source of light from this other side, what happens is, when you come this side to observe, you will see the light coming from where? You'll see the light coming from the other source, passing through all these boards up to your eyes. So what does that mean? You have already arranged this in line. And now that will mean that light, by the fact that you're seeing the source from the other side, it means that the light has traveled in a straight line. Now, what next do you do to disapprove that light travels in straight line? You can now, after arranging that, you've seen the light traveling in straight line. Try displacing one of these so that the hole is above, no longer in this line. What will happen is that if you displace this up or down, you will no longer see the light. Is that okay? That means that after the light passing from here, imagine that you shifted it and now the hole is up here. After shifting it, light will not come and then say bend and then come here. It will not. It will automatically be blocked by this. Is that okay? That is showing that light wanted to travel in straight line, but because you have blocked it, therefore you will not be in a position of observing it from this other side. So that is enough proof to show that light travels in a straight line. Is that okay? We said, what is the procedure? Arrange these 3 cardboards in line. Is that okay? After arranging them in line, using a string, put a source of light. That could be a candle, or we say it could even be a torch. And then, after arranging it in same line, in straight line, come and make observation from this side. You will see this light source, this other side. Is that okay? And then next, try displacing one of the cardboard. Maybe the middle one, upward or downward, so that the hole is no longer in line. Maybe the hole has shifted. What will happen is that you will no longer see the source of light from this other direction. And that will show that light travels in straight line. Is that okay? That if the hole is displaced up, the other will not bend to go up and then pass through. Is that okay? It will be blocked. Therefore, light travels in straight line. And that is enough propagation, and I mean enough proof that light travels in straight line. Is that okay? Good. So that is about rectilinear propagation of light. Okay? And then let's also look at what we are calling the reversibility of light. Reversibility of light. What does that mean? If we hear the word reversibility of light, what exactly comes into our mind when we say reversibility of light? Is there anyone who has an idea about that, reversibility of light? What does that principle state? If you hear reversibility of light, let's see what happens under reversibility of light. Reversibility of light states that the path taken by light is always reversed, isn't it? Or light can travel from one point to another, and also can, if you interchange the 2 points, it can also travel from the other point back to the other point. That's what we are calling the reversibility of light. Is that okay? It is a property that shows that light can travel. The path of light is always reversed. Is that okay? In other words, we can make a simple explanation using our cardboard here, that if this cardboard is in line and you happen to put your candle here and then you see it here, isn't it? It is also very true that if you shift this candle and bring this other side, and then also you come the other side, you will also see it, isn't it? And remember, light travels from the source going to the observer. So if it was traveling like this, and now you bring the source this side and then still see it, that means that light is still following the same path. Is that okay? So that's what we're saying, that the path of light is always reversed. Is that okay? And then in the next shift, we are going to look at some experiment to verify the principle reversibility of light. Reversibility of light. Let's look at that in our next shift. Thank you.